Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Tom Galluzzo, founder and CEO of IAM Robotics, a startup which specializes in building robots for warehouse operations. IAM's machines are quite different from other warehouse robots, the ones that tend to be called autonomous mobile robots, or AMRs. IAM's machine is called an Autonomous Mobile Manipulation Robot, or AMMR, which basically consists of a mobile platform with a robotic arm attached on top. The company also offers AMRs, regular AMRs, and other products and services, as Tom explains in the interview.
Tom Galluzzo, I'm the founder and CEO of IAM Robotics. What we do at IAM Robotics is build robots that are designed for logistics and material handling automation in manufacturing and in warehouse operations.
Right. I've been given some information about a FANUC event that you're involved in. But before we get onto that, if you don't mind, if I could ask you more about the company, because obviously this is the first time we're interviewing you, and we wouldn't mind some overviews of your company. So I'm at the website now, and the machine itself that I'm looking at is very complex with a robotic arm perched on top. It's some sort of mobile machine. I don't know whether to call it an autonomous mobile robot. The AMRs that I've seen are completely different from this. Other companies are actually working towards having a robotic arm perched on top of a mobile platform. You've already got there. So tell us a bit about this machine that I'm looking at, and any others that you might have at IAM Robotics.
Yeah, sure, certainly. So the machine you're looking at is a product that we have called Swift. It's what we call an AMMR, or Autonomous Mobile Manipulation Robot. And so it's a combination of a autonomous mobile-based platform, which would be your traditional AMR, with a vertical lift and a arm from FANUC. We're the first company, IAM Robotics is the first company to truly commercialize AMMRs. We have the ability to not only build the machines and the hardware, but we have the ability to we have all the software and autonomy capabilities on the robot to actually bring it to life. So the robot is driving around the facility using its own computer vision. It uses computer vision to be able to see and identify different items on the shelf. And we use the robot to batch collect goods. So it drives around and it grabs a batch of items that are typically brought downstream to some sort of sortation or put wall process. And so there's a human in the loop typically to actually do a quality check and verify and grab the individual items out, once the robot does all of the mundane work of kind of collecting the goods and bringing them home. We have also a number of capabilities to simulate and design solutions for customers using mobile robots and mobile manipulation robots. So we take a look at a lot of customer data in terms of, how many orders they're doing, their throughputs, what their order profiles look like, so that we can design how many robots they might need in operation, the layout, and so forth. What we've done is we've taken the base platform of Swift, and we're launching a new product, which is called Bolt, which is a more generic AMR, mobile robot, that's able to have all of the power required to be able to put, sophisticated toppers on top of the AMR, and to be able to supply power to things like conveyor tops or mobile manipulation, arms, new collaborative robot arms, and so forth. and we're seeing applications for those in, as I mentioned, both warehousing and manufacturing. So lots of exciting things going on.
Right. Just a quick question about the end effector. It's a suction device of some sort. Are there any other types of end effectors that this particular arm uses in its work?
We haven't done any other end effectors with Swift today, but we're going to be working with some integration partners to be able to put new collaborative arms on top of Bolt, and they're going to be using some other part end effectors to be able to move parts in and out of machines for machine tending. This would be applications where you need to, let's say, load CNC machines for factory automation, those kinds of things.
And the type of a warehouse, I suppose it's in the video I'm looking at, is a very neat warehouse with the products all sort of easily identifiable, perhaps. I don't know what other warehouses typically look like, but I've been told that it's quite difficult for a robot to pick out items in the way that yours seems to be able to do. Yeah, what kind of warehouse are we looking at in this video? And it looks like a pharmaceutical warehouse or beauty sort of products or something. Is that something you specialize in?
Yeah, absolutely. So that one with Swift is a health and beauty warehouse. We're doing another deployment with a company called AS Watson in the Netherlands, and they're using our robots to pick and manipulate products for a collection of bulk items in e-commerce fulfillment. We're also partnering, as I mentioned, with our new Bolt platform with a number of different integrators. One of them is called True Automation, and they're developing a conveyor topper for Bolt, so that Bolt can be used to replace some of the large, expensive sortation and conveyor equipment, complex conveyor networks within the warehouse. So it kind of frees up the operation for more flexible transport of goods within the facility.
And how has business been for you since the beginning? When did you start, and how have things developed, and how do you see things going for you?
Well, it's been really interesting, especially with COVID. Now we've seen a lot more interest pick up with folks that are kind of acutely focused on kind of the new demands that they're seeing for buy online, pick up in store operations, store fulfillment operations, e-commerce operations, and what we're seeing is kind of their plans for kind of expanding their automation, because they've underbuilt some of their automation that they need to grow into the demand that has picked up as a result of COVID, and some of the labor challenges that they had associated with that. So I think we've seen a spike of about 2x the number of conversations we're having, and new orders coming in for robots for deployment later this year and in 2022.
Right, and just one last question about the company before I move on to the FANUC event. Looking at something called I suppose a blog article which is titled ROI Modeling with Monte Carlo Simulations. I don't know what Monte Carlo simulation is, but I know what ROI is, return on investment. What is the return on investment on your machine? It looks very expensive, if you don't mind me saying. It's quite the machine. So I mean, what is the ROI on something like that? And how many typically, I mean, it depends on the size of the warehouse, I suppose, but how many machines do you imagine that a typical warehouse would need of yours?
It totally depends on the operation. We have various different deployments. I mean, some deployments are just a couple of robots. Some of them are over a dozen robots, and some that we're planning could be 30 to 40 robots. We have new applications coming out that are going to be designed for kind of our robots working with sortation machines to be able to automate the exit side of a sortation machine. And we're just seeing a very broad market in terms of the range of applications. I would say the average is probably at least 5 robots in a typical deployment. Our Monte Carlo simulation is something that's allowed us to get more sophisticated with kind of our planning. All Monte Carlo simulation is basically when you do a simulation, you normally have a set of parameters. You might simulate, let's say, how fast the robots drive, or you might simulate how many items an hour the robots are asked to pick up. Monte Carlo simulation takes that and extends it by saying, okay, maybe you have a range of speeds that the robot might drive, or maybe you have a range of number of items that the robot might need to handle. Instead of 200 an hour, maybe it flexes from 150 to 250. And what Monte Carlo simulation does is it runs thousands of different simulations and basically picks a new number somewhere within your different range parameters and says, okay, well, what if my labor cost is X and my number of items per hour is 235 pieces per hour, something like that. It does tens of thousands of these different scenarios, and you collect a statistical spread of what your typical ROI might be. So we try to identify solutions where we have let's say a 90% or 95% chance of getting a payback in under 2 years for a given deployment. And that very much depends on the exact nature of what the customer needs, how many robots they need. It even depends on the dimensions and the layout of the facility that you're putting the robot into. So again, this is why you have to kind of do a statistical modeling, or a Monte Carlo simulation is a good tool for this, because it allows you to get a very quick picture with a very broad set of inputs to simulation, or a spreadsheet model of what you might be planning out for a customer.
Okay, and there's quite a few interesting articles on your blog. I have to ask one more because it's an issue that I've been told about before. The article here is about conveyors. It mentions conveyors. Are there instances where your robots have either replaced conveyors or have kind of been chosen over conveyors by companies that are thinking about how to automate their warehouse, or theoretically could they be? And what is the kind of decision-making process when you're thinking about automating a warehouse? Should you use conveyors or robots like yours? What kind of judgments or considerations are taken typically?
Yeah, good question. So it's all based on kind of total cost of ownership of the conveyor versus the robots. We typically look at a 5 to 10 year total cost of ownership of the solutions, and you basically just compare two costs, cost of a conveyor solution or cost of robot solution. Typically, the robots will end up beating out the conveyor solution when your throughputs are lower, when you have a large number of sort points or pickup and drop off stations that the conveyors need to integrate into. So if there's a lot of sortation, or if there's a lot of transfer stations or different pathways that the conveyor needs to take, that can get quite expensive from a conveyor standpoint. With a mobile robot solution, maybe just a handful of robots might be able to replace many hundreds and hundreds of feet of conveyor. So this is particularly where the mobile robot solutions, just the AMRs, are starting to play stronger and stronger when competing against those classic hard automation conveyor solutions.
Yeah, I think one thing that comes to mind from conversations that I've had before is conveyors obviously are fixed fixed infrastructure, and they tend to be expensive and obviously less flexible than implementing mobile robots in a warehouse. So that's an interesting aspect of the whole trend of how to automate a warehouse. What do you think of the whole trend as well? I mean, how many warehouses It seems like a potentially a huge market. There must be, I think 50% of warehouses, this is just my guess, 50% of warehouses are not automated with robots, certainly. There may be even more than that. But what's your understanding of the market for, AMRs in general and your machines in particular?
Well, it's growing quite strongly right now, and we see probably a 5 to 10x growth in the next 6 years, I think, in the market. We're seeing new applications, of course, which are helping to drive that growth. We're seeing a shift in labor availability, which is driving that growth. We see strong interest in a couple of different areas. One of them is sortation robots, so using mobile robots to sort items to different points within a facility, or move items to different locations, point to multi-point drop-off. Another area is just person-to-goods solutions. So this is, robots with carts and so forth, being able to help guide pick processes for facilities that have a lot of manual walking and picking for e-commerce and omni-channel fulfillment. So we think that those areas in particular are going to be really strong growth areas for our products and for our integrator partners that are looking to augment classic solutions.
Right. Okay. And now the FANUC event that you're going to be involved in, where I think you're demonstrating your products, I believe. So tell us a bit more about that.
Yeah, so FANUC is launching a new collaborative robot arm. It's called the CRX. CRX10, I think, is the first model that they're launching. And we have some interest from clients that are interested in putting the new collaborative arm from FANUC onto our Bolt platform, which you've probably seen on our website. And so FANUC did an event here where they brought one of their arms to Pittsburgh. They have a strong regional presence here in Pittsburgh, and we were doing kind of a joint demonstration of their new collaborative arm with our new collaborative AMR Bolt. And we think these are kind of a match made in heaven. There's a lot of interest and attention for being able to do not only things with AMRs, but put robot arms on top of AMRs for new applications. And one of the advantages we have with Bolt is that, we have a lot of power, battery power on Bolt. Our battery is about 4 times the size of other AMRs in its class. And we have something called a power takeoff, PTO, interface on Bolt, which allows our customers to basically build custom tops on top of Bolt and be able to plug in their electronic devices into our power. So they don't have to have multiple batteries on Bolt. It's a single battery powering the whole application. And we have enough power available to be able to run the robot for 16 to 20 hours, depending on the application, of course, and depending on the kind of topper and power draw that you put on it. But I think we have the only AMR that's really designed for mobile manipulation, the fact that we have enough payload capacity, that we have enough power, the power takeoff interface, and all those things put together, along with the safety features of Bolt, allow you to do some really interesting things with mobile robot arms.
Okay, thank you very much for your time today and your insights.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.